video lesson, you are going to learn how to predict products of a chemical reaction when all you are given is the chemical formulas of the reactants. So this is putting it all together from all the lessons we've had so far in this unit. So if you are only given the reactants of a chemical reaction, you will need to predict the products of a chemical reaction, and you do that in 2 or 3 simple steps. First, determine the type of chemical reaction. Is it a synthesis reaction? Right? You can recognize synthesis if it's 2 reactants turning into 1 product. Is it decomposition? Decomposition is where you start with 1 reactant and it turns into 2 products or more. Is it single replacement, where maybe you have A plus, maybe you have A plus BC turning into B plus AC. Or maybe it's double replacement, where you have AB plus CD turning into AD plus CB. Or maybe it's combustion, where you have some kind of hydrocarbon, some number, which is carbon, some number of carbons with some number of hydrogens, maybe an oxygen or a nitrogen thrown in there. But you will always have O2 as a reactant, and you will always have CO2 and H2O as products. Okay. So based on the reaction type, right, if you can recognize these patterns that you're starting with, you can determine the products of the reaction. And you're going to do that by writing first the correct chemical formulas for each product. Don't worry about balancing yet. The key thing is to write all the correct formulas for all the products. Don't worry about balancing until you've written all the chemical formulas. Okay, so that'll be the trickiest part. Once you have all the correct chemical formulas written, then you can go back and balance each reaction using the correct coefficients. So let's dive in. Our 2 reactants here are CH4 and O2. This looks like a combustion reaction because I have a hydrocarbon and I have oxygen. That means I'm going to have CO2 and water for products. I'm going to go ahead and put blanks in front of it because once we know our chemical formulas and we're confident our chemical formulas are correct, then we can go ahead and balance. Okay, so let's taking a look at this one. I've got 1 carbon, 1 carbon. I've got 4 hydrogens, only 2 hydrogens here. I'm going to double that. That's going to give me 4 hydrogens. That's going to give me 2 plus 2 oxygens. So 4 oxygens on the right side. I'm going to need to put a 2 right there. So this equation is now, we predicted the products to be carbon dioxide and water, and we've balanced it with the correct coefficients. Okay. Let's take a look at number 2. Also a hydrocarbon with some oxygen mixed in. Adding oxygen to it, again, we're going to get CO2 and water. So simple products to predict because they always are going to be those, combustion will always have CO2 and water as products. So here I have 2 carbons, because now I'm going to balance it, right? So 2 carbons, 1 carbon. I got to put a 2 in front of the CO2. Hydrogen, I've got 6 hydrogens on the left, but only 2 on the right, so I got to put a 3 in front of the water. That's going to give me a total of 4 oxygens plus these 3, so 7 oxygens total on the product side. I've got 2 oxygens here and 1 here. If I put a 3 in front of that O2, that's going to give me 6 plus that 1, and so the oxygens are also now balanced. So that's how you work through that one. All right, let's take a look at the non-combustion reactions. Taking a look at number 3. What I have here is I have an element and a compound. So this is going to be single replacement. And because this element is a non-metal, that means I need to make this chlorine nonmetal switch places with this iodine. So that means calcium is going to be left all by itself. So I'm going to have calcium all by itself, and I'm going to put a blank in front of it so I remember to go back and balance it. And now I have to figure out what my new formula is going to be when I put, well, no, that's not right. let's go back and do that again, Mrs. Lee. All right. The chlorine and the iodine are going to trade places, so it is the iodine that is going to be left all by itself. Hope you had a pencil. Sorry about that. The iodine is going to be all by itself, but iodine is a diatomic. It's one of the diatomics, so we have to make sure that that's an I2. That means I have to put the calcium together with the chlorine. So we're going to do a little side work right here, right? So calcium is a +2, and chlorine is a -1, right? This is an ionic compound. Metal, non-metal, I have to do the whole ion charge thing, drop and swap. So this is going to become CaCl2. So this is where it gets tricky, right? We got to predict the formulas first. Now we have to recognize, well, maybe this is balanced, maybe it's not. I believe it is balanced. 2 Cls, 2 Cls, 1 calcium, 1 calcium, 2 iodines, 2 iodines. So this is all ones. You don't have to put the ones there, but that's the emphasis is that it is already balanced. All right, so this next one I have is also single replacement, but I'm going to be replacing the metal this time because the metal, the element that was all by itself was a metal to begin with. So over here, it's got to be the magnesium metal all by itself over here. That means I'm going to put the sodium together with the nitrate. So when I put sodium and nitrate together, I have to forget about how many I had over here, and I have to do the little side problem of what is this chemical formula when I put sodium ions together with nitrate ions. Okay, so that's going to be NaNO3. Balancing this equation, it looks like 1 sodium, 1 sodium, 1 magnesium, 1 magnesium. But here I have 2 nitrogens and 6 oxygens, so I'm going to fix that by putting a coefficient in front of the NaNO3. When I do that, it makes my sodiums not work, so I'm going to have to go back and fix that with a 2 in front of the Na. So that's how I work that problem. So that's how you do single replacement problems. Definitely a little tricky. These next two equations are decomposition problems. I know this because there is only one reactant. So when you have one reactant, we are going to write whatever these elements were in their elemental form on the product side. So nitrogen in its elemental form is a diatomic. We have to write it as N2. Hydrogen in its elemental form is also diatomic. I have to write it as H2. So I know that there were 3 hydrogens here. I know there was only 1 nitrogen, but when you're writing these elements by themselves, nitrogen and hydrogen both have to be diatomic. So I got those formulas written. Now I have to balance the whole equation. I see right away that nitrogens, I have 1 versus 2, so I'm going to put a 2 in front of the NH3. That's going to balance my nitrogens. That's going to give me 6 hydrogens, but I can fix that easily by putting a 3 in front of the H2. So that equation's done. H2O2. I'm going to break this down into the 2 elements that are there, hydrogen and oxygen. Hydrogen's going to be diatomic, oxygen's going to be diatomic. And lovely enough, this one is already balanced. That's just great. All right. Lastly, we have here synthesis. How do I know? I have 2 elements coming together. The only thing that can happen is a synthesis reaction. So when I put Na together with oxygen, I can't just say NaO2. I have to look at those. It's a metal-non-metal combination. It is ionic, so I have to look at the ions. I have to know that sodium in its ionic form is a +1, and oxygen in its ionic form is a -2. So dropping and swapping, this formula becomes Na2O. Right? So I just am writing one product because synthesis, 2 reactants turning into one product. Now, taking a look at this, I see right away that I see sodiums are not balanced. I see oxygens are not balanced. If I put a 2 in front of the sodium, that fixes the sodium. But in order to fix the oxygens, I have to put a 2 in front of the sodium oxide. So that fixes my oxygens, but now that throws off my sodiums. I need a total of 4. So this actually needs to be a 4. 4, 1, 2. All right, last one, also a synthesis reaction. I know this because I have only two elements. The only thing that can happen is to form one product in the compound form. So that means I'm going to put a metal together with this nonmetal. I know that this is ionic. I have to look up the ion charges from the periodic table. Magnesium is a +2, nitrogen is a -3. So this formula here has to be Mg3N2. And now I can go ahead and balance it, right? So really the N2s are already fixed. They're already good. So all I need to do is put a 3 in front of the magnesium, and the other coefficients are 1s. All right. So in this lesson, we have learned how to predict the products of a chemical reaction, knowing the patterns that exist in these 5 reaction types. And when we write our products, if it's an ionic product, we have to look at ionic charges. So we might have to go visit the periodic table, or we may even have to go visit reference table E for those polyatomic ions. All right, that's it for this lesson, and that's it for this section in Unit 5, and so I will see you back in the classroom.